Hello everyone, this is Geneva Oraño, and I will be solving problems from the Advanced Engineering Mathematics 5th edition by Wiley and Barrett. So the first problem is found on page 107, number 65. Using variation of parameters, obtain a formula for a particular integral of the following equation: y 4 prime minus 5y double prime plus 4y equals f of x. So first, we will transform this equation into m to the 4th minus 5m squared plus 4 equals 0. From this auxiliary equation, we will get negative 2, negative 1, 1, and 2. Since these values of m are all distinct, the corresponding solutions are y sub 1 is equal to e to the negative 2x, y sub 2 is equal to e to the negative x, y sub 3 is equal to e to the x, y sub 4 is equal to e to 2x. So after this, we must now find 4 functions of x, say u sub 1, u sub 2, u sub 3, u sub 4, such that y is equal to e to the negative 2x u sub 1 plus e to the negative x u sub 2 plus e to the x u sub 3 plus e to 2x u sub 4. So set this to 0, we will get e to the negative 2x u sub 1 plus e to the negative x u sub 2 plus e to the x u sub 3 plus e to 2x u sub 4 equals 0. Differentiate this thrice, so we will get first negative 2 e to the negative 2x u sub 1 minus e to the negative x u sub 2 plus e to the x u sub 3 plus 2 e to the 2x u sub 4 equals 0. Differentiate this again, we will get 4 e to the negative 2x u sub 1 plus e to the negative x u sub 2 plus e to the x u sub 3 plus 4 e to the 2x u sub 4 equals 0. And last, differentiate this, we will get negative 8 e to the negative 2x u sub 1 minus e to negative x u sub 2 plus e to the x u sub 3 plus 8 e to 2x u sub 4 equals 0. So with this, we can now solve for the Wronskian. So our w of x is equal to 72. Then after solving for this, we can now proceed to solving u sub 1 prime. So to solve this, we will set this side to 0, and we will get negative 6e to 2x f of x over 72, or negative e to 2x f of x over 12. For u sub 2 prime, we will set this to 0 and divide this by 72, and we will get 12 e to the x f of x over 72, or e to the x f of x over 6. For u sub 3 prime, we will set this to 0 and divide this overall with 72, and we will get negative 12 e to the negative x f of x over 72, or negative e to the negative x f of x over 6. And for u sub 4 prime, we will set this to 0 and divide this overall with 72, and we will get 6 e to the negative 2x f of x over 72, or e to the negative 2x f of x over 12. So substituting these values to this, We can now obtain a formula for a particular integral of the following equation, which is y4 prime minus 5y double prime plus 4y equals f of x. And the result is y equals negative 1 over 12 e to 2x times integral e to 2a f of a dA from 1 to x plus 1 over 6 e to the x times integral e to the b f of b db from 1 to x minus e to the x over 6 times integral e to the negative cf of c dc from 1 to x plus e to 2x over 12 times integral e to negative 2g f of g dg from 1 to x. The second problem is found on page 108, number 73. The problem states that under what conditions, if any, can table 2.2 be used to find a particular integral y of a constant coefficient nth order non-homogeneous linear differential equation if n is greater than 2. So, the conditions are if the non-homogeneous term f of x is a solution of a constant coefficient homogeneous linear differential equation, or if f of x possesses only a finite number of linearly independent derivatives.